Right. Get this recording and we'll get going. So today we are talking about data validation. I have to say this class in general has a lot of topics that are like among my favorites to teach, but I don't always get the opportunity to teach because they're sometimes like a little bit tangential to what we cover in a traditional statistics class. And so I just want to thank you all for giving me this opportunity because this stuff is so fun. So today we're going to be talking about ways to basically make sure that the data that we are working with is good. And it turns out that the stuff that we're using here is like not even half the battle. I'd say it's like 2/3, maybe 90% of the battle is making sure that your data is good and giving you what you would expect. And if it's not giving you what you would expect, that you can figure out why and answer those questions prior to trying to fit any kind of statistical model. Often the statistical model is the kind of last step that you layer on. All right. If you would like to follow along, as always, this little bit.ly link will take you to the slides. So this time, got a little -3 here. So bit.ly BEM 392 S22 slides 3. I also have put, if you notice in Canvas, I have kind of all the different pieces for the lectures in there too. So you can get to the slides from that, as well as any kind of material that like reading or things that you might want to look at for some extra information, should you be interested in doing that as well. You'll also notice, I'm going to mention this at the end, but there are two things in the like after class section for today in Canvas. One is a reminder. So when in the very first class, when we talked about design principles, you did kind of two little mini exercises. One where you thought about the design principles for your project solo. And then the second is when you thought about it with your partners within your project. And step 3, there was one more little survey to fill out that you need to do by the end of the month, which is kind of after corresponding with your client, reassessing those and seeing if they are the same as what you had expected or maybe a little bit different. So just putting in those rankings one more time is for that. And then the second piece that's in there, I have something that I called a module 2 check-in, which is, it's not graded or anything. It's just sort of an opportunity if you have things like feedback, things that you wish you had seen in module 2 that you think would have been useful for people that are taking this class in the future, or just general style things that I can sort of tweak. That's a place to stick that. And in addition, I have 2 questions for the next 2 modules, which is the next one is data visualization. The one right after that is on regression. And so if there's like one thing that you think would be really useful for me to cover in those sections, like one piece that you think is going to be particularly useful maybe for your project in particular or for kind of where you think you're going next, go ahead and write that in and I'll try to incorporate as many of those as I can. I just want to make sure that these are sort of highlighting the pieces that you're going to find most useful for what you're doing next, because that's the whole purpose of this class, is sort of to recap what you've already seen. It's not supposed to teach you anything brand new, but sort of recap what you've seen in a way that like frames it in a useful for your next steps way. And so because this is my first time teaching it, it really is, I greatly appreciate any kind of feedback that you all can give, because I obviously want it to be useful for you. It would be terrible if it was just like a waste of everybody's time. Okay, so the plan for today, I'm sorry, I'm always so out of breath because I run from another class to this class. I can't quite catch my breath in time. All right, so the plan is we're going to talk about first something known as column names as contracts. I linked on Canvas to a blog post with this idea. So if you had a chance to look at that, that's great. If not, we'll talk about it and you can go back and look for more details afterwards. And then we're going to talk about data cleaning in R. I'm going to show you the tools that I usually use. If you've learned different tools, that's fine. This is sort of just that I find the ones that I use for me personally were the path of least resistance. So you're welcome to adopt those or try to keep doing what you're doing, but just to sort of see a way to do that. And then finally, we'll talk about some data validation tools, where the big picture is we're sort of taking what we've learned from software developers who build things like unit tests to test different pieces of their software. And this is like a really useful type of mentality that can be applied to your data sets. And so we're going to talk about a package that you can use to be able to do that, to kind of be able to set expectations for your data set and then check that those expectations are actually met. Okay, so this woman, Emily Ryderer, she is a She works, I think she's a data scientist at Capital One. And she has this great talk as well as blog post on this idea that you can use your column names as a way to align producers of data sets and consumers. And basically treating your column names as like a set of rules, similar to how we talked about how your file structure should have some kind of system and your file names should have some kind of system. You can apply those same principles to the column names in your data set, and it actually can make it much easier to be able to do things like data cleaning and summarization and stuff like that if you can adhere to these kind of principles. And it also can help you kind of, as we had talked about last time, either to align with another data analyst that kind of agrees to your same column name contracts. So like within an organization, you can set up expectations so that if someone sees a data set, they know exactly what columns contain based on what their names are. Or if that other analyst is just yourself in 6 months, it can also just help to sort of have that expectation upfront. So what do I mean by that? So I mean kind of setting some terms that then have like definitions, and these should be like somewhat both machine and human readable. So they don't need to be like long, but they do need to be kind of clear enough for a human to sort of understand what they are. So here's some example terms: ID, IND, YN, val, cat, DT, and TM. And the semantics behind those terms, for example, in my kind of column name is contract setting that I've set up here, ID is always going to be a unique identifier. And this is important because later when we're going to be doing some testing, if you know that a variable that has the term ID in it is a unique identifier, then you would expect that column to be distinct. So every value in it to be distinct. So you can test for that later. IND, an indicator, is going to be a binary 0, 1. The rest of the name is going to describe condition 1. YN is going to be a yes/no variable. So this tells you that everything in that column is going to be either yes or no. Val could be numeric. Cat could be human readable. DT could be a date, and TM could be a timestamp. So the actual terms that you use, you don't have to use my terms, but just sort of the idea of setting terms and expectations for those terms is the big picture. And so that's the term, that's the semantics. And then there's a contract behind it that like ID will be numeric, it's a primary key, that an indicator will always be 0, 1, that YN will always be yes or no, that DT, a variable that starts with DT, will always be a date and it will be in this format, things like that. So you can set up these basically expectations for your columns based on their names. And you can have like basically multiple different versions of this. For example, I could have types, I could have question type, and I could have details. And I could define each of these using that semantics and contracts kind of setup. And I can use these to sort of construct my variable names. And so here I'm referring to that same data set that we used last time, the Star Wars survey data. And you could imagine me basically creating variable names by pulling from each of these columns in sequence. So here are some examples. I could have a variable YN underscore scene underscore, and then it would either be Star Wars or Star Trek, depending on which column I'm referring to. So YN scene Star Wars would be a yes/no column, and it would answer this one of the questions about have you seen this yet? And the answer and the details would be either Star Wars or Star Trek. So it would say like yes, no, have you seen Star Wars? And we would expect everything in that column to be either yes or no. And similarly, there were a bunch of questions about whether you were a fan of different things. And so I could have another set of columns that start with YN, and that the second part is fan. And then I would have kind of, depending on which column it was, I would have a different one of these. There were a bunch of questions that asked how favorable you found different characters. So that I could start with cat, because these are going to be categorical. There were like 5 levels of favorability. And I'm indicating that the question was one of these favor questions. And the character that's being asked about would be the last part of that variable name. So does this kind of track why we would do something like this? So it turns out that using this type of, not only does it sort of organize your data set in a way where if someone else was looking at it, they can easily figure out the types of variables that are in it. So like the first column can help you check types. It also has the nice ability that you can then kind of parse these variable names and do different things when you're either cleaning your data or summarizing that use that information as part of it. So it saves you some coding time as well. So let me show you an example of what I mean by that. So when you're making tables, using that GT summary package that I had mentioned before, you can take your Star Wars data and you can select the variables that you want to include. And so let's say I want to make a summary table with only numeric or demographic variables. I can use these little functions, which we'll talk about in a couple of minutes, which kind of come from the tidyverse package that nicely will pull kind of accordingly. So for example, if I want to pull all numeric variables, I can select the variables that start with val, because I know that by my contracts, that's going to pull everything that's numeric, because the val start of a variable name indicates that it's a value or some numeric. Or if I want to make a table of only my demographic variables, I can use this contains function. And so this is going to select only columns where the column name contains the word demographic. And because of the way I've structured these contracts, I know that that's going to that'll pull in all of those variables and put them in my summary. So does this kind of track why something like this would be somewhat sensible? Yes? Okay, great. So we're going to do a quick application exercise to get started. So I want you to go to this bit.ly BEM 392 S22 RStudio. And what it's going to do is it's going to take you to that RStudio Cloud, that RStudio Cloud workspace that we had worked in before. And I want you to save a new permanent copy. So don't open your old one from last class. Go to this link again and save a new one. And the reason we're doing that is because I've actually updated that kind of initial workspace with some new packages, and I've changed some of the details and things like that. And so you're going to want to get a new one as opposed to using the old version. I'll give you just a second to go there, and then I'll go there as well. All right. Go ahead and go to that RStudio Cloud space. And in the top, kind of right, you should see something that says like make a copy. And go ahead and do that so that you can copy this to your own space so you have a place to work in it. If you'd like to name it something different so it doesn't get confused with your last one, you're welcome to. You can also delete the one from last time if you'd like to, although if you wanted to save something in there, you could just create a new one. And so this is going to be a very similar workspace as before. If we look in our files, we've got our code, our data, our README, and our reports. And we're going to work through some data validation and data cleaning here. So the first thing I want you to do is, yes?
So it said, you said like to save like a new copy. You're not save like maybe the old copy, but why does it like save a new copy?
Oh, that's fine. Save a permanent copy. Yes, that's what I meant. What I meant was not to go. So don't go to like the one that you did last time and just open that. Go to the new link. Yes.
I don't have an option.
You don't have an option. Did you go to this link?
Yeah, mine doesn't. I'll try it again.
Okay. So the difference is if you just go to RStudio first instead of going to this link, then you might see. You got it? Okay. 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 So everyone, okay. Everyone looks okay. Good. Okay. So go ahead and open the readme.md. Either click preview or visual editor so that you can see it kind of in rendered markdown. And I want you to figure out two things from that information you can see there. How is the gender variable coded? And is age continuous or binned? And then I want you to find the file where the data is cleaned and open it. I'm going to give you a couple minutes to do that. You can talk to your partner next to you about how the different variables are coded and where you would maybe find that information, and then see if you can find the data cleaning file as well. Okay, this like time, I always have a hard time judging. How is everyone doing on time? Is this too much time? Have you already done the things on this list? Do you need more time or less time? You got it. You did them. Okay, I'm gonna pause this whole timer and we'll keep it going. And you can give me some feedback on the time pieces because I feel like I usually don't give people enough time. So I've tried to create these timers, but then sometimes they feel too long. So how is the gender variable coded? Yes.
It's categorical, so it says category. Sorry, no, it's individual. So it says or binary. So it's binary.
Yes, exactly. So it's an indicator variable with 1 and 0. Exactly. And what about age? How is age in this data set? Yes. It's binned. Exactly. It's categorical. And hopefully you're able to find the data cleaning file as well. So we're going to take a detour into a little bit about data cleaning. And then we'll get to practice a little bit on our own. So the first thing is pipes. I use pipes a lot when I'm coding. The name comes from the Magritter package. This says it's pronounced and then, and by that I mean when I'm reading my code and I see a pipe, I usually say something like and then. So for example, I might say take the data and then make a table. And so the pipe is basically saying what's going to happen next. And you can think of it basically as a sequence of actions. So here's an example that I like to give. The sequence of actions would be like, you're gonna find a key, then you're gonna unlock your car, and then you're gonna start your car, and then you're gonna drive to school, and then you're gonna park. And so the way that R works, if you're trying to dictate a sequence of actions or a sequence of functions that you would like to fit, R reads from inside out. So if you're gonna do this as nested functions, which is sort of the more traditional way to do it, you would need to read it kind of from the inside and out. So this is what I mean. If I were to turn these actions into kind of the pseudocode, I would have to first find my keys, and then I would start the car with those keys, and then I would drive, and then it could have some argument like to campus, and then I would park. So basically the way that R works, it kind of goes from the inside out when you're reading code, which sometimes I find a little bit hard from a human readable perspective. And so this is where the pipe comes in. This exact same code can be rewritten using a pipe. And so all the pipe does is it puts the previous piece into the first argument of the subsequent piece. And so, for example, here, I'm going to find my keys and then start the car. So it's taking that find keys output and it's piping it into the first argument of the start car input. And then I'm going to drive, and you can use arguments still, like further arguments. So the first argument of the drive function is going to be the output from these two. And then you can have subsequent arguments as well. And then finally, that final output is going to be piped into the park function. So I find this a little bit more legible, but you are not required to use it. But just so you know, in my code, when you see pipes, that's what it's doing. It's just taking the previous output and putting it in the first argument of the subsequent function. And you can actually send results to function arguments other than the one, than the first one. And so you do that using a dot. So for example, if I wanted to take some data and filter it, so it's taking this data and it's putting that data in the first argument of the filter function, and I'm filtering it to only include humans. I could pipe this into the LM function to fit a model. The first argument of the LM function is the model itself, so that's not where I want to pipe it. I want to pipe it into the data argument, so I can use this dot to indicate that. So the pipe basically is just a way to sort of split out your code so it's a little bit more human readable, where it's just sticking the thing on the left side of the pipe into the first argument of whatever it is on the right. Okay, so data cleaning. I like to do my data cleaning using the dplyr package, which comes from the tidyverse. So the tidyverse is basically a suite of packages that kind of have similar semantics, and dplyr is one of them. And so the things I'm going to cover today are basically the most common parts of data manipulation that you will probably find yourself doing. It's going to be filtering. So that's basically if you want to pick rows matching certain criteria. Selecting, which is if you want to pick columns based on certain criteria. Arranging, which will be to reorder, so that's like sorting. Mutating will add new variables. Distinct is going to filter for unique rows. This is kind of commonly done if you're trying to kind of only pull out maybe one observation per individual. And summarize, which will reduce variables to values. There are a lot more functions that you can use, but these are going to be the ones that we talk about today, since for most data cleaning purposes, this is what will serve you pretty well. And so some dplyr rules for functions. The first argument is always going to be the data frame, which is nice because it allows you to sort of clean your data in this linear format using the pipes. So the first argument is always going to be the data that you're trying to apply some action to. And then the subsequent arguments will say what to do with that data frame. And the output is always going to be a new data frame that like has the things that you would like, so that whatever you did to that previous data frame, the new data frame will have those next pieces, which is going to be why that can sort of be piped in this linear fashion. And this part, I think everyone in this room is very familiar with R, so this should be something that you all already know, but it doesn't modify in place. So that's in opposition to something like Python or other languages that modify in place, which means if you edit a data set, if you filter a data set, it's like that data set is now saved as the filtered version. In R, if you do something to an object, it doesn't change the object unless you overwrite it or save it afterwards. And so filtering a data frame doesn't automatically mean that the data frame is filtered in the background unless you save it as a new object or the same object that's filtered. Okay, so for example, here's how we would filter. So the filter function selects subset of rows. So if I only wanted to subset to Star Wars fans, I could take my data frame, Star Wars survey, and I pipe it into the filter function. And I want to only include individuals that have the answer yes to this YN fan Star Wars question. So this will filtering selects rows. You can also filter for many conditions at once. So when you have multiple conditions, it treats them as and clauses. So for example, if I want to have a data frame that only includes Star Wars fans who are female, I would do it like this. I would take the Star Wars data set and pipe it into the filter function. And now I have two conditions. I want this variable YN fan Star Wars to be yes. And I want this to be, and I want the indicator for demographic female to be 1. Now, one thing you'll notice here is you've got this double equal. Why is there a double equal and not a single equal there? What is it? It's a comparison, exactly. So in R, a single equal sign in R is actually, can be the assignment variable, which often you use the assignment like the little arrow in R, you know. You can also use an equal sign. And so when you're trying to test an inequality, you need to distinguish it from that assignment, which is why you need a double equal. So the double equal is actually a test for equality. So this, if you ran this in R by itself, it would just give you a bunch of true false output. So these are all the different logical operators in R that are commonly used. These, I think for most of you should be familiar, but just so you have on a slide, if you need to refer to it later, I thought I would stick them on here. So we've got the less than or equal to, greater than or equal to, exactly equal to. So again, you need that double equal sign. Not equal to, you can have the ampersand indicates and the pipe, the like up and down pipe indicates or. You can test if something is missing or is not missing. You can test if it's a subset of something. So this in, if you have like a character vector for Y, you can test if X is in that character vector. And similarly, you can have not, test if it's not in a character vector. Okay, so filter is for filtering rows and select is for keeping variables. So you can think of filter being sort of like filtering down a data frame and select being selecting across a data frame. And so here I have filtered the data frame to still include only when Star Wars is yes and the female is 1. And then I've selected only columns that contain the word rank. You can also select to exclude variables. And so if you have a minus sign in front of a variable, it'll exclude it. So for example, if I wanted to delete the ID column, I can select -ID, and that will give me a new data frame that includes all of the columns except for the ID variable. You can also select a range of variables. So the way that I've named these variables, we've got a question about whether the survey recipient has seen episode 1 through episode 6. So there are 6 different questions about this for each of the 6 episodes. And I can use this colon here to basically indicate that there's a range, because there's this number at the end of my, at the end here, and it'll look across those. And actually the way that the colon works is it does it based on the order that the columns are in the data frame. So if you wanted to select columns like from the 1st to the 5th or something like that column, you can put the first column name, colon, and then the 5th column name, and it'll select all the ones in between as well. All right, so select is for selecting columns, filter is for filtering rows, distinct will filter for unique rows. So for example, let's say I wanted to select just the age and education variables, and I want to know only what the distinct combinations of age and education attainment are in this particular data set. I can do that with this distinct function. And the arrange function will arrange these alphabetically. So I can then arrange these by age and education should I want to look at something like that. GroupBy allows you to do calculations on group. So for example, if I want to get the average rank among people who have seen Star Trek, I want to know how they would rank episode 1 on average. And so what this will do is it'll group by this question, yes, no, seen Star Trek, and it'll calculate the summary within each of those groups. And so I'll end up with a summary among those who saw Star Trek and a separate summary among those who did not see Star Trek. So basically this will group by whatever variables you stick in here. And this is quite useful. This type of language is very similar. If you ever end up working in like a SQL database, they use very similar type words to describe these. And so that's another reason I like dplyr, because it sort of translates nicely between other languages that you'll probably find yourself using commonly when doing kind of database manipulation. Count is another one that I find myself using often for counting observations in groups. So for example, I just want to know how many people fell into each of these groups. That count is, it's a simplification of doing like a group by and then summarizing and count and summing up each of the responses. You can, a shortcut is to just use the count variable. Mutate adds new variables. And so here I am adding a new variable called cat demographic age recode. And to do that, I'm using this case when function, which basically acts as kind of like a long if else. And so it takes the cases and it tells me what I would like to do in each of those cases. So on the left side of the case when arguments are going to be a logical statement. And on the right side is going to be what to do should that logical statement be true. And so here I'm adding a new variable to my data set called cat demographic age recode. And it's going to be the case when the cat demographic age variable is missing. So when is.na is true, I would like for this variable to be na underscore character. So this is just a specific type of na that's a character vector. So I want my recoded age to still be missing if my actual age in my data set is missing. And then I would like for my new age to be, if my categorical age is either 18 to 29 or 30 to 34, I'd like my new age to be 18 to 44. And if my new age, or if my old age was in 45 to 60 or greater than 60, then I want my new age to be 45 plus. So I've essentially I've recategorized my age variable to be either 18 to 44 or 45 plus. So I've reduced the categories there. And one thing to note, and this is that kind of not saving in place piece. So most often when you define a new variable with mutate, you also want to save the resulting data frame, often by overwriting the original data frame. And so by that, I mean you want to assign the output of this to whatever data frame that you whatever you'd like to call this data frame. So here, I've done that by this assignment arrow and Star Wars survey. So basically it's overwriting my old version of Star Wars survey as being exactly the same, but having this extra variable that I've just created. You can also do this at the end of your pipe. The arrow, this is like not a widely known fact, but the assignment operator in R can go in either direction. So you can also assign it the other way. This is actually more commonly how I do it, but people feel strongly both ways about it. So you're welcome to do it either way. But the big picture is if I didn't do that, if I just ran this part without that arrow, it would just print in my console the output of this data frame, but it wouldn't actually save it anywhere because R doesn't save in place. You have to like tell it to save the output somewhere. So if you add a new variable, you always have to save it into a new data frame. Okay. And then the last part, when you're making new variables, it's always good practice to check to make sure it actually did what you think. So for example, here I could use the count function to check my new recoded age against the actual age. And what I would expect to see if it had worked is that basically anytime that my old age was between 18 and 44, then it would have, it'd be a 1 in the age, or it would be indicated in the age recoded, and when it's greater than 44, it would be indicated as well. Okay, so here's an application exercise. There's a couple things going on here. I want you to go ahead and find that, data cleaning file, which if you didn't find it before is in the code folder under O2 clean data. And first, I want you to examine lines 8 to 13 and see if you can figure out what's happening and add a little comment to explain what I was doing there. You can talk to your neighbor about that if you don't know, or if you'd like to just share. And then I want you to create a new variable, cat demographic age 2, that has 2 categories, less than 30 or 30 plus. And then I want you to write a little check and just run in the console to make sure this worked. And then I want you to write that data to a CSV file, clean data, data.csv. And then I want you to add that new variable that you just created to the data dictionary table in the README. So you're going to be first just looking at the code to see if you can figure out what's going on in lines 18 to 13 and add a comment, then create a new variable, check the variable worked, write your data to your cleaned CSV file, and then add it to your data dictionary. Okay, I'm gonna start. Is that okay? Okay, I'm gonna start going through it. Let's see, let's open this project. All right. So who can tell me what was going on in those couple of lines of code up here? Anybody know what's happening here? I'm gonna make it a little bigger. Yes. Yes, you are. Yes, exactly. So the very first, this first part is the logical statement is checking whether all 6 are NA. So it's checking the 6 columns is YN seen episode 1 through YN seen episode 6. If the answer was NA for all of them, that basically indicates that they likely didn't answer the question ever. So for that, we're gonna just say, we're gonna have that be missing. And if it wasn't NA for episode 1, then it's going to be yes, and otherwise it's going to be no. Does that sound good? Now, what am I assuming with this coding here? Yes. Yes, exactly. I'm assuming it's binary. And one thing that's like somewhat crucial is I'm assuming that everybody in this data set has seen at least one film. So I'm giving them, if they didn't answer any of those, if it's missing for all 6 of them, then I'm assuming that means they just didn't answer the question and not that they truly didn't see any of them, which might not be the right assumption. It might, the better, a different assumption, if I had understood kind of better how that question was asked, I believe it was a series of checkboxes. And this is kind of like when doing any kind of data analysis, it's good to sort of show your assumptions up front, because it's possible that somebody just didn't check any of those boxes because they truly have never seen a Star Wars movie, in which case then this should have actually been NA. Is there a way that I could check if they've ever seen a Star Wars movie? So there's a variable called yes, no, seen Star Wars, where some of them are actually no. So they've never seen a Star Wars movie. So what I can do is I could add another line here that could say, if the yes, no, seen Star Wars, if that was equal to no, then I would want this to be no, because if they've never seen any Star Wars movie, then I can assume they've never seen episode 1 as well. And so that would maybe be a cleaner way, and I can add that to all of these lines here to sort of make sure that I'm not missing any pieces. Does that make sense? Just to understand how what we're doing here? Okay. So great, that's what that line was doing. The next part was to add a new variable called cat demographic age 2 that categorizes for less than 30 to greater than 30. So can someone walk me through how I'm going to do that? I'm going to uncomment these lines to start. So this top line is saying I'm taking the data frame called D and I'm piping it into this mutate function. And what is this arrow D? What is that doing? Yeah. Exactly, it's overwriting D to make sure it includes this new variable that I'm creating. Very good. Okay, so I've got case when. What am I going to stick in this case when in order to create this new variable, cat demographic age 2, that categorizes to less than 30 or 30 plus? Yes. So first I want to make sure that I catch all my NAs and stick those as NA as well. So there's the variable cat demographic age is what this is going to be based off of. So if it's missing, then I want it to be an NA character. Very good. And it's always good practice when you're making a new variable to do something explicit with the missing variables, because that's usually where data errors come up. So often when you're creating new categories, the biggest place where you can end up accidentally categorizing people in the wrong spot is with missingness. And so I always like to have a very specific line to say exactly what I want to do with missing data, should it exist. If there were no columns that were missing, so if age is never missing, it won't hurt anything to sort of have a condition that checks for that. All right, what would I do next? What's the next category? Yeah? Exactly, cat demographic age. Well, what you have to do here, so the in, what this is doing is it's checking for conditions. So you would have to use exactly what the variable, what the strings are for that cat demographic age. So one thing sometimes I like to do is check what those are. There's different ways to do this, but one could be to just use the unique function. And I can check unique cat demographic age, which will tell me the unique values that I can then plug into this. So if I want it to be less than 30 or 30 plus, the only category that's less than 30 is this 18 to 29. So I can use the in and just put that one category. This will work. But because it's just one value, I can also do this. I can also check it with the exactly equals check. So either of these will work. I'm going to do this one just to show kind of two different ways to do it, because we're going to use in next. Okay, so if the cat demographic age variable is equal to 18 to 29, what do I want my cat demographic age 2 to be equal to? Yes. Less than 30, exactly. All right. And then what am I going to do next? What would I check for the next piece? Yeah. Exactly. So I can use these values here for 30 plus, which turn out to be this 30 to 44 greater than 60 and 45 to 60. So I can put I would put those in this, so 30 to 44. So it's going to check for any time that that is equal to any of these values, 45 to 60 or greater than 60. Then I want it to be equal to 30 plus. Is there another way that I could do this? Yeah. I could, yes. So instead of this, I could also just say where cat, because these are exactly exclusive and because I have already accounted for my NA variables, I could just do this, 18 to 20. So when age is not equal to 18 or 29, then it's greater than 30, because I know what my categories are. So I know that the only ones remaining are going to be that. And there's actually one other way I can do it. You can use just true, because the case when function operates linearly, so it'll first check for the condition and categorize those people and take them out of the subset. And then it'll look for the next condition, categorize those, take them out of the subset, and then look for the final condition. And so because everybody, if I've already gotten rid of my NA people and I've already gotten rid of my folks less than 30, the only people left are going to be greater than 30. I can just say true and call this 30 plus. So this kind of recoding, I know this might feel a little bit boring, but this kind of recoding is like really, really common. And hopefully this will help, these kind of tools will help you be able to do that efficiently. So I'm going to run that. And now I can rewrite my CSV file by running this write CSV. And now my data is going to be overwritten with this cleaned data here. And so let's just make sure that did the whole thing. So I'm going to run that whole piece to make sure that it overwrote correctly. All right, go back to the slides. Okay, so tidy selection. So this is kind of a motivation for why it's really useful to use those kind of column names as contracts type principles. So anywhere you can select a column by name, you can use these tools. So this could be for data cleaning, or as I showed in that example, it could be for creating tables, for example, using like the GT summary package, or it could be in data validation, which we're going to see in a second. And so these are sort of the key words for tidy selection. So this is like ways that you can refer to particular columns. The first is everything. So that will just be all columns. This is the default for most functions. We'll just take all the columns. You can also use the last call, which will select the last variable of your data set. You can use starts with, and so this one is going to be very useful for the way that we've constructed our variables, such that the first part of the column name indicates the type of column it is. And so if you just wanted to select all categorical variables, you would take that Star Wars data frame, and then you would select variables that start with cat, for example. You can also do ends with. Contains will take any variables that contain whatever phrase it. So like the demographics, for example, that keyword fell in the middle of my variable name. And so I would use the contains function in order to match columns that have that. Matches will match a regular expression. Num range will match a numerical range. All of will match all of the columns that you specify in there. And then where could apply a function to all the variables and select those where the function returns true. So here's an example from data cleaning. For example, if I wanted to, this is a super common one. I want to take my Star Wars survey and I want to find all of my yes, no responses. So I'm mutating across. So across is a really helpful helper function when dealing with these different tidy selectors. So I'm mutating across all columns that start with YN. And based on my column names as contracts, I know that the column names that start with YN are all going to be either yes or no. And I can apply a function to all of those, to all the data in those columns. So in this case, I'm going to apply the to upper function. So that makes it all uppercase. It's really useful because a lot of times when you have variables that are character strings, depending on how those variables were input, they might have a variety of uppercase and lowercase. And so if you want to kind of do something systematic across your full data set, you want to make sure that that's consistent so that you know kind of what to expect. So this is an example of being able to use these tidy select functions in data cleaning. You can also do it as I showed before with tables. So for example, if I wanted to make a table that only included demographic variables, I can select just the columns that contain the word demographics and create my table from that. So this is a really big time saver. I don't have to go through and type out every variable name. I can just do that. Another is for calculation. So for example, if I wanted to summarize across just columns that contain the word rank, I could calculate a median for all of the ranks like this. Instead of having to separately type in all those column names, I could just use the across and contains function together. Okay, so that's a motivation. This next part of today's lecture is going to be on data validation. So after you've done your data cleaning, you want to validate that your data set actually is as you expected it to be. And there's this great package called Point Blank. I put a little trailer in the, a link to it on Canvas that I encourage you to watch. It's like 2 minutes. It's just the author who made the Point Blank package made this little video that's like a little hype up video for the package, which I think is kind of hilarious because it has like James Bondy kind of music in the background. But essentially the Point Blank package is a way to be able to evaluate whether or not your data set is as you would expect it to be. And it uses a lot of kind of like agent and interrogation type puns in the function names as well. So this is like the big picture. You take your data frame and you use this create agent function to sort of get things started. And then you have a bunch of validation functions where you basically validate the different columns in your data frame, follow expectations. And then you use the interrogate function to run those validation functions, and it gives you an output that lets you check. So this is sort of the concept framework of what we're going to be doing. I found it a little bit abstract when I first was looking through this, but hopefully when you see like the actual code, it'll make a little bit more sense. So there's a whole bunch of different validation options. I've listed here, I don't know, what is this, 8, 9, 10, 11, 12, 13, but there are a whole bunch more. I'll show you where you can find more details. But for example, you can check, are all the data in these columns less than some specified value? Or are all the values equal to some specified value? Or are the column data part of a specific set? Or are the rows in this column distinct? And so things like that. So you can check basically, these are basically like unit tests to make sure the data is as you would expect it to be. So instead of having to check each column one at a time, you can just add these, and every time you rerun your data analysis, it'll rerun these checks to make sure that everything is as expected. You can find all of them. This link here has the package details, and under reference here, you can see all of the potential checks that you can do. And in fact, there's an article here on data quality reporting that includes a nice long list of all the different types of ways you can check your data, with links where you can click to see how those functions actually work. So if you're interested in kind of further exploring more than what I'm going to show today, you can do it there. That's it. This site, .github.io/point-blank. Okay, so this is how the code works. Here's an example. I'm going to load the point-blank package, and then I'm going to take my data frame and I'm going to pipe it into this create agent function. So this is just sort of to get things started. I'm going to create this agent, and then I'm going to pipe that into a series of data checks. So for example, I'm going to check that there are no null values in the ID column. So based on my expectations, everyone in my data set should have an ID. So I want to make sure that there are no missing values there. And I'm also going to check here that the column rows, the ID columns are all distinct so that everyone has a unique ID. And then I can check whether columns are character vectors. All the columns that start with the word cat should be character vectors based on what my expectation was, based on how I read in this data. So I can check that. And I can also check things like, for example, any column that has the word rank in it, I know should be a rank between 0 and 6. And I also know that there might be some NA values, and so I'm going to have this NA underscore pass equals true to allow for there also to be NA values. So basically what you're doing is you're taking your data frame and you're running a whole bunch of data checks, like little data unit tests across the different columns to make sure that it's as you would have expected it to be. And then I run the interrogate function at the end to actually get the output. And so this is what the output looks like. It gives you this nice little interactive table. And so it shows you each of those checks that I had. So for example, the first one was call vals not null. I expect that all values in the ID column should not be null. So the column that's getting checked here is ID. And I can see that this there were no evaluation issues. It checked 1,000 rows and all 1,000 passed. So this column is whether it passed, and 0 failed. And similarly, I can look at this rows distinct, expect entirely distinct rows across ID, and similarly that all passed. Okay, here's another example here. I'm going to take that Star Wars survey. I'm going to check that the values are in a set. And I'm going to look at this yes, no, seen episode 1. And the set that I'm expecting is yes or no. And then I'm going to interrogate it. So I'm looking at this one variable, yes, no, seen episode 1. And I'm going to check that all of the values fall within this set. And when I run this, I can see what I've run here. I'm expecting the values in the yes, no, seen episode 1 should be in the set yes or no. And it's not super obvious, but this check actually fails 351 times. And so over here in the fail column, I see 351 times that it fails. And in the pass, it passed 835 times. And it gives me this little CSV file. So there are 351 fail rows available. And I can actually click this and it'll download a CSV file that shows me exactly where this failed so I can see what's going on. One thing to add here is you can add these action levels, which will warn at a certain level. So that will make this output a little bit more useful. So I'm going to create this action where if 10% of my data fails my check, I'm going to get a little warning. And depending on like how severe a failure would be, you can set that warning at a lower threshold. So if any of your data fail, for example, you could set that to 0. If any fail, you would get a warning. So I'm setting it at 10%. And I come back here and I see, oh, I do have a warning here. That's what this little dot is, and also why this is yellow. Up here, it reminds me that I set my warn threshold to 10%. And so that tells me that more than 10% of my data is failing this check. And it turns out here, this is because we also could have NA variables. So I needed to add NA to my set of potential values. And so once I do that, now my warning is no longer there. I have 0 in my fail. I have all 1,000 that pass. And this goes back to being green. Okay, so what I want you to do is we're gonna do this now, and we only have 15 minutes left in class, so I'll let you spend about like 8 minutes or so doing this, and then I'll jump in and do it with you. But what I want you to do is open the reports, report.rmd, and I want you to create the following data checks. I want you to first check that variable that you created, that cat demographic age 2, has exactly 2 categories, less than 30 and 30 plus. So make sure that you created that variable correctly. And then I also want you to check that all yes, no variables contain only yes or no, and that all favor variables have the right categories. And then if you see a mishap, I want you to go back to the data cleaning file and see if you can figure out how to fix the mishap. Okay, I'm gonna start. Has anyone, let's see, who has done a check for your categorical variable to make sure it worked? Someone want to tell me how to do it? Yes, Noah. Okay. What is it? Oh, go ahead. Yes. Call vowels into. So perfect. Just to clarify real quick. I read in this data frame as Star Wars survey up here, which is why I'm calling it that instead of D. And then I started down here in this little point blank chunk. So I've created the agent here and I've set my warning. So that's, but yes, okay, so call vowels and set, and then what's gonna come next? Cat, demographic, age 2. Less than 30, 30 plus, and NA. Okay, let's just run this to see how it works. Make sure I'm gonna pipe this into my interrogate function. Let's see what happens here. Oh, I need to run my previous code. Oh, did I run? Maybe I didn't. Oh, call vowels instead. There we go. All right, so now it's running these checks and I get this nice little output down here that shows me whether or not it passed or not, and it's gonna be way down here at the bottom. Call vowels and set, cat demographic, age 2. It looks like 100% of them passed, so perfect, okay. The next one was to add a check for all yes, no variables. Can someone tell me how to do that? Yes. The call is logical. Okay. Starts with YN. And that's it. So this, I think this is gonna fail because I'm pretty sure this is checking for it to be a lot. Let's try it. Let's see what happens. Yeah, so here, all of those failed, which is what this warning here says. The condition was not met here in 100% of the time. And the reason why it's failing is because that call is logical. You can see what that is actually checking whether it contains logical values. So like true or false values, which in this case, we know that the YN are gonna be character variables that are like in a set. So, but that was good. It was a good try. I'm glad you tried it. That was good. So I'm gonna use call vowels and set instead. Does someone have a suggestion of what I should put as my set? Yes. I'm gonna try yes, no, NA, character. And what I'm gonna just comment out the rest of these checks just so we can focus on this one. But at the end we can uncomment them so we have them all. So let's see what happens here. Okay, so it looks like it checked 11 variables and I have 4 that have warnings. And I can tell that those have warnings because here I've got this little yellow on the side. And also if I go over to this where it tells me how many units passed and failed, I can see that 100% of my units failed in the scene Star Wars variable. And I can see that 836 of my units failed in this yes, no fan Star Wars. And if I want to see exactly what that looks like, I can click on the CSV file and it'll actually download a file that shows me where all of those failures were. But I also can just look at those columns in my console to see if I can guess why they might have failed. So I'm going to do that down here. So let's see, let's take a look at that Star Wars survey. I want to look at the yes, no, seen Star Wars variable since that's one that failed. Okay, so looking at this output, can you guess why my check failed? Lowercase, is that what someone said? It's lowercase. So my check was checking for yes, no, where the first letter was capital, but in this particular variable, it looks like yes, no is all lowercase. I manipulated this data. So the way it came in from 538, it actually was consistent, but I manipulated it so you had something to see in a data check purposely. So the way that we would fix that is we'd go back to our data cleaning and we can mutate. We can take, and actually let's do it at the top here. We're going to take all the yes, no variables. So all variables that start with yes, no, and I'm going to make them lowercase so that I always have, so I always know what to expect. And then I'm going to change all of these yeses with a capital Y to yeses with a lowercase y. And I'm going to change all my no's with a capital N to no's with a lowercase n. So I've done two things here. My main one is that I went across all variables that start with yes, no, and I've made them lowercase. And I've cleaned my data now to do that. So now this check should pass. And the last check, which we have like 1 minute to cover, was to check that all variables that contain favor have the expected set. So this is the expected favor set. I typed it in so you don't have to do it yourself. And so I'm going to check that. Did anybody get to this part? No. Okay. So I'm going to check all the columns that contain the word favor. And I expect the set to be this expected favor set. I'm going to reread in my data since I just cleaned it up a little bit to make sure I've got my cleaned data. I'm going to pipe that into the interrogate. So it looks like there is a problem here. What is the problem? Yes, it should be contained. Thank you. Perfect. Oh, and did I save expected? Make sure I saved this correctly. Expected, oh, I spelled expected wrong. Okay, there we go. So now I can check if these conditions were met, and it seems like it's still having some issues here. So, oh, I didn't change that because I made them all lowercase. I'm going to change these all to lowercase. Let's rerun that and make sure. Okay, so it looks like everything passed except for one. There's one warning in step 20. And so we can go down to step 20 and see what the warning is. And I can see that the categorical variable about Boba Fett has 138 times that it fails. And I can take a look at that CSV file to see exactly what's happening where it fails. And it will output the data frame or the whole data set where that takes place. So I could open it and look at it, or because my computer's being slow, instead of opening it, we can just look at that variable. So let's look at survey. We're going to select cat favor Boba Fett, and I'm going to look at just the distinct values. And I see that it looks like they're not exactly the same. There's one of the categories, instead of being just those 5 that I've picked, the very favorably category was replaced with a different category. And so then I would have to go back and clean it. And I think it's time for you guys to go. So I'll let you all go. But so this is basically a way to be able to check that your variables match up with your expectations, which hopefully will provide useful before you even started your analysis. So please fill out that module 2 check-in before sometime next week, just so that I have time to be able to incorporate any suggestions you have. If you have suggestions specifically for data visualization, which we're going to start on Wednesday, try to get it in before Wednesday so that I can prep for that as well.
Thank you.